Okay, hello class. This is a video for the last segment of alcohol. We learned before that alcohols have three main reactions. First, combustion, which is the same as the rest. Secondly, there's also dehydration, where by eliminating one molecule of water, we can get back an alkene. Okay. So last, we have oxidation. Alcohols can be oxidized into carboxylic acid. So just to recall, what do we mean by alcohol? Let's say I have ethanol. If I oxidize it in the presence of an oxidizing agent, there are two examples that we will be using in organic chemistry as oxidizing agent, namely KMNO4 and K2Cr2O7. Note that they must both be acidified. Okay, so after we add the oxidizing agent, you can see that it becomes a carboxylic acid. Okay, how can we tell that something is oxidized or reduced? Okay, recall that to tell whether something is oxidized or reduced, there are four methods. First, number of oxygen atoms, then number of hydrogen atoms, gain or loss of electron, then lastly, oxidation state numbers. Right? So how can we tell that alcohol in this case has been oxidized? Okay, there are two ways. You can see that the number of oxygen atoms has increased from one oxygen atom to two. We can also say that there are lesser hydrogen atoms, but usually we go by the more straightforward way, which is that the number of oxygen atoms has increased. Okay, so there's actually a hidden condition in the type of alcohol that we choose. Not all alcohol can give us a carboxylic acid. What do I mean? Okay, note that in this case, the alcohol functional group, the hydroxyl functional group is at the end of the molecule. Okay, because I'm using ethanol, it's always at the end. Okay, so let me give you another example. Say instead of ethanol, we have instead of ethanol, let's say I have propanol. Okay, so if it's a propanol, what is the compound that will form upon oxidizing it? Okay, think about it for a while. Can I form a carboxylic acid if my hydroxyl group is at the center? Okay, think about it again. The carboxyl group requires 3 bonds. Okay, and so the carbon is only left with 1 bond. Therefore, the carboxylic group is always at the end of the molecule. So what happens if the carbon that the hydroxyl group is attached to is in the center? It's not at the ends of the molecule. In that case, when I oxidize it, I would only get what we call a ketone. Okay, a ketone, this compound, has appeared in your quiz. Okay, this is known as propanone. Okay, which is a ketone. So if you see it ends with ONE, it means it has a what we call a carboxyl group in the center. Okay. So because of this, there are a few classifications of alcohol. Okay, so what is the specific type of alcohol that we must use to form a carboxylic acid? If the carbon that the hydroxyl group is attached to is only attached to one other carbon, 2 hydrogen, then this is known as a primary alcohol. This is known as a primary alcohol. Okay, if your carbon that the hydroxyl group is attached to two other carbons, this is known as a secondary alcohol. If the carbon that the hydroxyl group is attached to three carbons, then what type of alcohol is this? It is a tertiary alcohol. Okay, so primary, secondary, or tertiary alcohol is dependent on how many carbon atoms the particular carbon that the hydroxyl group is attached to is connected to. Okay, sounds very confusing, huh? So again, if the carbon that the hydroxyl group is attached to is only attached to one other carbon, it is a primary alcohol. If the carbon that the hydroxyl group is attached to two other carbon, it is a secondary alcohol. If it's attached to three, then it will be a tertiary alcohol. So, of these three types of alcohol, which is the one that will give me a carboxylic acid? Yes, it is the primary alcohol. So, can you just note in your note that primary alcohol, when we oxidize it, it can give us a carboxylic acid. Okay, if we oxidize a secondary alcohol, we will get a ketone. Then what about a tertiary alcohol? Can I oxidize a tertiary alcohol to also give me a ketone? Okay, think about it. No, it's not possible. Okay, why is it not possible? Because to form a ketone, it's a C double bond O. So I'm using up two bonds. I can only form two other bonds with two other carbons. But a tertiary alcohol already has three bonds with three carbons. So it cannot spare that two bonds to form with oxygen. Okay, so we have only primary and secondary alcohol can be oxidized. Primary being oxidized to a carboxylic acid and secondary being oxidized to a ketone. For tertiary alcohols, they cannot be oxidized. So let's take a look at what are the reactions. Okay, what will we observe when we add ethanol to acidified K2Cr2O7? Which species is oxidized and which species is reduced? Can you explain your answer? Now try this yourself first because we have already learned about K2Cr2O7 as an oxidizing agent. Okay, what is the color change? Okay, so what is the color change? It is from orange to green. Do you still remember what is the compound that is green? Let me use green also. It is Cr3 plus. Whereas here, this is Cr2O7 2 minus. Try calculating the oxidation state of chromium in these two ions. Okay, that will help you answer the next part. So which species is oxidized and which is reduced? Explain your answer. First, ethanol is oxidized to ethanoic acid because there's a gain in oxygen atoms. Then, the chromate ion is reduced to the chromium ions because there's a loss in oxygen atom, or we can say that there's a decrease in oxidation state number of chromium from +6 to +3. So, make sure that you know how to calculate the oxidation state number for a polyatomic ion such as chromate. Okay, time for more general knowledge. Why does wine turn sour if it has been open for a few days? think about it in your head, must have something to do with alcohol. Okay, what are the reactions that it can undergo? So the correct reaction is alcohol. When you leave it open for a few days, bacteria will convert the alcohol into carboxylic acid and water. So why is it sour? It's because of the presence of carboxylic acid. You know that if it's ethanol, then it will become ethanoic acid, which is actually like in your vinegar. Yeah. So the sour taste comes from the acid. Just for you to recall, how do alkalis taste? Okay, alkalis taste sour. So carboxylic acid tastes sour. Alkalis taste bitter. Acids taste sour. So I mean, you don't want to drink like vinegar, right? So I guess there are people who do, but not me. So not judging or anything. Okay, so this is just the ending activity. Can you add all the reactions that you have learned today in the reaction map that you have drawn for alkenes? There's the carboxylic acid that's not, currently blank, nothing is moving there. So can you add in the reaction from alcohol to carboxylic acid, as well as from alcohol to alkenes? So that's all for this lesson. Thank you.